For a couple of days, we were looking into multicasting. In the last class, I showed you a demo by configuring PIM dense mode and IGMP to join a multicast group. We did a lot of testing by enabling the group member, disabling the group member, and so on. We generated traffic by using ICMP when I pinged. The echo request packet was sent and reply was coming only from the group members. But I also showed you a drawback. What is that? The multicast packet was going on every PIM enabled link. Even those links where there is no group member. Even those links where there is no group member. We are receiving the multicast packets. So, what we need to do is we need to change to another mode instead of dense mode. We need to change into another mode which is called as sparse mode. Sparse mode. The dense mode is called as source base tree. Source base tree.
Thank you, sir.
Source based tree is what we saw. Meaning the control plane of multicast get built when you try pinging group member. And you saw that in the multicast table. When I type show mroute, it was showing you the inbound interface and outbound interface. And when there is a receiver, you saw it was forwarding. And when there is no receiver, you saw it was pruning. Which is source-based tree. Not scalable because it is flooding all the multicast packet on every PIM interface, even when there is no receiver. So with this topology, we joined the multicast group 239.1.1.1 on R2, R4, and an R5. When you ping from here, that destination 239.1.1.1, you got reply from 245, but when we check the mroute table, you are able to see the source and the group on every router, including 3, 6, and 7. If 3 is having the info, it is okay because it's in the path. It's in the path between R1 and R5. But why should R6 and R7 know the source and the group member when it don't have any group member? It's unnecessary. We need to avoid this. Not only that, let us say we have another multicast address 239.2.2.2 on R6. Assume R6 has joined this new multicast group. When I ping this address from some router, maybe same R1, when I ping from R1 239.2.2.2, we want the response from R6. That will happen But we do not want R7 or any other router to know about source and this group. See, when you ping 1.1.1 239, we want only R2, 3, 4, and 5 to learn. And when I ping 239.222, we want only R6 to know, no other routers. So when depending on what address you ping, the tree should be formed. That's what we want. But is that we see? We don't see that. We see source-based tree, meaning when I ping from here, based on the source, the tree gets developed. Wherever the ping goes, the branches becomes the control plane. Right? So we need a control plane with only relevant routers and relevant information. We don't want every router to know about all source and all group members. The dense mode that we saw, it will have information about this group member as well as this group member on every router, which is not irrelevant, which is irrelevant. We want this group information to be seen only on R6 and on R1 because R1 is the source. No other router should know about 239.222. But in the dense mode, you cannot achieve it. In dense mode, you will have a common control plane for all the routers in this topology. Common control plane. Source-based tree. We don't like this. So we have to change it to different mode called sparse mode. In sparse mode, we will have a shared tree. Meaning this topology will be shared with different group, and as we expect, only R6 and the source member will know about this 239.222. So there's going to be a separate tree, like this one tree, means one topology. And for 239.111, this tree, you will have this tree. This is what called a shared tree. The topology has been shared with two trees. You can have any trees. If you have more multicast group, more trees. The root may be same or different also. If you are pinging all the multicast from the same source, then the root is going to be on same router. If not, from different router. Sparse mode will give you shared tree. Okay. Now, how is this possible? If R6 is not sending any multicast packet on this link. If R6 is not sending any multicast packet, if R5 is not sending anything that it has received, though PIM is enabled, what does that mean? It means that these routers are clever. These routers know that there is no one to receive. Then why you unnecessarily forward? How this knows, how R6 and R5 knows that I should not send it via this link? Because there is no one there to receive, I should not send it via this link. How this router knows it? How R6 and R5 knows that I should not send it to R7? It is through a mediator. That mediator is not in dense mode. That's why dense mode was flooding to every PIM enabled multicast links. And when there is no receiver, it pruned. It was unnecessary flooding and pruning. In a dense mode, it was unnecessary flooding and pruning. I can show you that quickly. So you see, we had this topology in the past, in the previous class. Again, we are having the same one now. When I try pinging the 239.1.1.1 with source of my loopback 0, I will be receiving some. Okay, here I can see that R2 and R4 only has got this group, no other router. But R7 also will know about this source. Show IPM route. Look at this. Oh no. Okay, maybe it was not ready when I pinged. Now let me ping again. R1 ping. Going back to R7, you see, it is unnecessary for R7 to know about this. And you can see it is pruned also. It's not needed. Why? Unnecessary flooding on this link, occupying the bandwidth when there is only two members. Only two members. Who are they? R4 and R2. These are the two members in this topology who wants to receive the signal. But it was disturbing 3, 5, 7, 6. Let me show you on 5. See, 5 also knows about it when there is no receiver. Here I have written 5, but 5 I have not really, I have disabled, I think. Let me show you. Show run interface or show IP IGMP membership. It is not having membership. 239. Do you have 239? No. This is Cisco. By default, Cisco will have 224.0.1.40. I showed you. I told you this in the previous class. 5 is not a member of 239.1.1.1. Whereas 4, if you see, show IP IGMP membership. This says it's a member of 239.1.1.1. So 5 is not really a member. Now what I'm going to do, I'm going to do something different what we have not done in the previous class. I'll remove this 5 from this multicast group and I'll create another one. 2.2.2.2 group, and I'll add R5 to it. Let me go to router 5 and join the group. Interface loopback 0. IPIGMP join group 239.2.2.2. Now if you see show IPP membership, you see R5 is the only member. It don't know the source. Right now it knows only that it wants to be a member of this group. Now I'm going to ping from R1. Ping another address. This time, who will respond me? Only 5 will respond me. But unfortunately, every router will know about. What happened? Oh, no. I put a wrong address. It's 222. See, only 5 is responding, but unfortunately 4 will also know about it. 4 is not a member of the group. It is only for 239, but in the mroute table, show IP mroute, it knows both, which is unnecessary. It knows both. You see, this one which I accidentally pinged, that one is also registered. It's not necessary. R4 need not to know about this group and this source. Why? When there is no one to receive, why should it learn? Why should it learn? If it has learned, which means the bandwidth between R2 and R4 was consumed unnecessarily. How can we prevent this? We can prevent by enabling sparse mode instead of dense mode. Right now, all the routers are running dense mode. Show IPPIM interface. All run the mode called dense. Welcome to the world of sparse mode. What is sparse mode? Shared tree. What it means, how it is possible. You see, we will have one mediator called rendezvous point. A rendezvous means gathering point. To that meeting point, whoever wants to join a group should come and register themselves. For example, I'll make R1 as a meeting point, assume. R1 is the meeting point, rendezvous point. R1 is not a source now, R1 is a meeting point. The reason why I'm making that as a meeting point is all the links are connecting to R1, that is why. Usually, you know what we do? We take some router which is in the middle of the topology and we will make it as a rendezvous point. We can also make R3, but you need to connect between R3 and R2, R3 and R6. So some router in the middle, we will make it as a rendezvous point, meeting point. So every router, when it joins a group, say for example, 2 and 4, router 2 and router 4, when it joins 239.111, it will come to the meeting point. It will come to the rendezvous point router and say, rendezvous point, rendezvous point. I need any packet that is sent to this address because I am member of that group. So they don't, simply be quiet. When you configure IP-IGMP join group, immediately that router will go and tell rendezvous point that I'm a member of this group. If you will find any source for this group, connect me to the source. Connect me to the source. For example, if R6 is the source, assume R6 is what? R6 is source. Source for what? 239.101. If R6 is a source for this multicast address, there will be a tree built between R4 and R1. See, this is a rendezvous point. As soon as you say here IP IGMP join group 239.1.1.1 on R4, R4 will go to RP and say, I belong to this group. Now, R1 knows that there is someone called R4 who wants the packet that is sent to 239.1.1.1. R1 knows that this link I need to forward because there was a registration coming via that link. Now, when you ping from here to this address, when the source sends a packet, that is what ping means. In our example, we are using ICMP to ping. Immediately, R6 will not flood it to anyone. R6 will go to rendezvous point. R6 will go to our rendezvous point and say, hey, I am the source for 239.1.1.1. So what happens? R1 will inform R4 that for this group, the source is 6.6.6.6. Now what R4 will do, it will check the routing table, how to reach 6666, and it will form a tree like this. A tree will be built like this. So anything R6 send will go only to R4 and the routers in the path. No packets will go to R3, R5 and R7. Yes. The link between R1, R3, R5, R7 and between 6 and 7 will never be utilized, will not be wasted. The bandwidth will not be consumed. These routers will never know that there is a source and group called 239.1.1.1, source called 666.6. So the bandwidth between this port will never be used by the multicast traffic because there is no receiver there. So there is no flooding via R3. R1 will not flood the packet via F01 port. R1 will not flood the packet via 1/0 because there is no one to receive. Likewise, R6 will not flood the packet via F01. Now, we don't waste the bandwidth. We don't unnecessarily send the multicast feeds to all the routers. It goes only to those routers which are relevant. You see, there is no flooding and pruning. So what is the secret? We have a rendezvous point. We have a meeting point. So every router should know this meeting point, right? Otherwise, how they will come and register? How the source will go and say, I'm the source? So we need to have a RP, rendezvous point. RP. So in a dense mode, we don't need RP because in dense mode, when a multicast packet comes, all PIM enabled interface will forward it because they don't know where the group members. But in the sparse mode, when a multicast packet wants to be sent, it will go straight to the RP. Likewise, RP will also forward the packet only via those links where the group members are because the group members come and register with RP. So through the RP, Group member knows the source, and source knows the group member's location. As a result, there is no need for flooding. The control plane is built only based on the location of the group member, not flooding. Yeah, so you know about broadcast is bad, flooding is bad. Even though it is a multicast, wherever the PIM is enabled, it is flooded. It's almost equal to broadcast. But if PIM is not there, it won't go. So I cannot say broadcast, but still, kind of. Sparse mode is like flooding and pruning only. Sorry, dense mode. Sparse mode uses rendezvous point. So every router in sparse mode should know the location of rendezvous point. Who is a rendezvous point in our case? R1. In our example, R1 is a rendezvous point. That should be configured on every router, including 3, 5, and 7. Even if you don't have members, you need to configure rendezvous point. Why? In future, you may go and configure a member. You may make R5 as a member of this one. So as soon as you make membership to a multicast address, R5 should know the location of RP to go and register, saying, I belong to this multicast group. So sparse mode uses rendezvous point. And this rendezvous point should be known to every router, which was not there in dense mode. Now, knowing about RP can be static way or dynamic way. Statically, you can go and say to every router that 1.1.1.1 is the RP, which is not possible in a large environment. Or if you keep changing RP, then it is not easy to go to every router and change the RP address. So what we do is we use different protocol methods to dynamically learn RP. One of method is what called as anycast RP. Okay, before going in, I want to talk about auto RP. Auto RP is a Cisco's idea. In order to learn the location of RP, in order to know the location of RP, it will flood and learn. That's why no one you want to use this one. You saw, no, there was a multicast address even when we have not configured. Every router was a member of 224.0.1.40. What is this? This is the multicast address to which the flooding will happen to discover the location of RP. And once discovered, then it won't use this multicast address. Just to learn the location of RP, they use the dense mode concept. That is what auto RP. That is only available in Cisco router. To support the auto RP only, we have this 224.0.1.40 and also one more address 224.0.1.39. 39 and 40 is reserved to Cisco for auto RP purpose. But that is not popular because it is Cisco proprietary. We have another method. The best one is this one, BSR, Bootstrap Router. Another one, Anycast RP. Anycast RP is also popular. BSR is also popular. or you can also statically configure RP. So these are the ways in which every router can know about the location of RP so that they can go and register and so that they don't need to flood everywhere. As a summary of today's class, what I want to say is in the previous method, we were flooding the multicast packet to all the links that are that's enabled with PIM, which is unnecessarily consuming the bandwidth and the processors of routers. Even the unintended routers will receive it and drop it, which is called pruned back. To avoid that, we have a RP rendezvous point in sparse mode, which solves the problem by allowing the group member and the source to register so that through the mediator, through this RP, group member will know who the source is so that it can use reverse path forwarding to know the location of the source. For example, R4 will know that my source is 6.6.6.6. So it uses the reverse path forwarding, meaning it checks the routing table how to reach 6666. And from there, it sends the request and gets the feed. The tree is built now. The shared tree is built like this. Only one branch via R1. Now to know the location of RP, two methods. One is static method, another one is dynamic. Static method is you going to every router and configuring the IP address of RP. Dynamic method is using like BSR or auto RP or anycast RP. Right? So any question on what we have learned today? R2 should receive because it has to forward it to R4. Yep. The devices in the path has got no other go. See, that's why what I was telling you is if you would have had a link like this, and if I make R3 as an RP, then you don't have unnecessary hops learning. Okay, anyway, R2 should learn, but R1 will not come into picture then. See, right now, R6 is the real source, R1 is the RP, R2 is unnecessarily involved in the middle. If I have a middle router, we can avoid more routers getting disturbed. That's what I mean. Usually in our enterprises, we'll have full mesh design. All router will be connected to all other routers. So you will not have much hops unnecessarily learning. Yep. Yeah, as soon as you put the IGMP command, because it is a sparse mode running on the link, PIM immediately will look for RP and take this IGMP group member address and enroll with RP. So the enrollment was happening via this link. So R1 understands that if I receive any packet to 239.111, I have to forward only via this link, not via any other link, because the enrollment was coming via this link. So multicast feed will be sent via that link. R2 will forward it to R4. When I do the lab, you will have this in much more detailed clarity. Yes. PIM. Same procedure. See, same ICMP only. Sorry, IGMP only. But it will be done through an application. We won't be typing this command. The developer who has developed that application to make use of multicasting will have that IGMP there, will also have the multicast group address there. As a user, you will not know. You will simply double click and install an application. But that application is inbuilt with IGMP group member like 239, whatever, given to the company. Say, for example, for Cisco, I showed you 224.0.1.39 and 40 for this purpose. Likewise, for AutoRP. Likewise, for every developer, software developers, there is a need for an address to be purchased. So you buy a address, multicast address, and you will use only that multicast address in your application. So when a client server relationship applications are installed in your organization, the server is going to be the source of the multicast feed, and all the clients will be joining that multicast group, but you will not be typing the command anywhere, IP IGMP join group, whatever the address. That is taken care by the application. And your PCs will send the request to the nearest gateway. And the gateways are having PIM enabled. And the gateways are going to forward the enrollment request to RP using the PIM. Right. Fine then.